Okay, guys, I'm going to look at a system of inequalities here. So, just like a system of equations, how it's more than just a single equation, a system of inequalities is more than just one inequality. So let's see what we got to do. So what I'm going to do is I'm going to do one of the inequalities in blue, and I'm going to do the other inequality in red, just so we can keep track of everything. So let's look at the blue one. So I'm going to do the boundary line for the blue. So that's 4x plus 3y equals 12. Okay. So 4x plus 3y equals 12. Let's look at an x-intercept. That's when y is equal to 0. So that's going to be 4x is equal to 12, or x is equal to 3. Okay. So I'll start graphing. Let's just start graphing down here. X and y. So I know I'm going through 3, 0. Simple enough. And I'll check my y-intercept. That's when x is equal to 0. That means 3y is equal to 12, meaning y is 4. Okay, so that's going to be right up here. 1, 2, 3, 4. So that's the point 0, 4. So this is less than or equal to, so it can be part of the line, and it is linear, so I'll draw my line in. And let's finish this one up. Let's test some points. I'll pick the easy test point of 0, 0. That would say, if I plug it right into here, 0 plus 0 is less than or equal to 12. That's true. So I'm going to shade this side horizontally in blue. Okay, so you can probably tell what I'm going to do here is I'm going to superimpose these two inequalities on top of each other and see what satisfies both. That's where we're going with this. Okay, so let's go to the red equation over here. Let's do our boundary line like we just did. That's going to be y plus 4x is equal to negative 4. Let's start with an x-intercept, which we know is when y is equal to 0. Okay. So if y is equal to 0, that means 4x equals negative 4, or x equals negative 1. That's down here. That's right there. Okay, so negative 1, 0. Let's do our y-intercept. That's when x is equal to 0. That means that y is equal to negative 4. 1, 2, 3, 4. 0, negative 4. Once again, this thing is linear, and it is greater than or equal to, so it can be on the line. So I'll just draw this in, and it just kind of keeps going up, something like that. Now, let's pick a test point. So I'll go ahead, I will test, let's test 0, 0 again. Why not? It's easy. 0 plus 0 is greater than or equal to negative 4. Looks like 0, 0 checks out. So I want my solutions to that one are these red lines. See that? So what is my overall solution? Well, it's wherever these are overlapping. So it's this sliver right here. So that's what I'm really going to shade in as my actual solution. Okay, so there it is right there. Now, one thing, especially if you do any linear programming at any point, so it'd be bad if I didn't show you this, it's very important to know these corner points a lot of times, where these two lines intersect. Because a lot of times with linear programming, you'll get these polygons and you have to check each corner to try to see which are your maximum and minimum values. Very useful in application. So let's see if we can find where these intersect. Think about if you can try to figure out where those two lines intersect. Do we have a method of doing that? I mean, I think in 9.1 and 9.2, isn't that sort of what we were doing in the two-dimensional case? When we had two variables, we would find x's and y's that would make both equations true. But what did it mean geometrically? Oh yeah, it was where the two lines intersected. It was that point that we want. That's what we were finding. Okay, so let's try to figure out what this is right here. Okay, so it's where the two lines intersect. So we just have to solve the two boundary lines. We're going to set up as a system of equations and figure out what x and y are, and that's where this intersection point will be. So let's write that up here, how about? So I have 4x plus 3y equals 12. That's the first boundary line, the blue one. And the red one, see how it's y plus 4x? I'm just going to change the order on that. I think that's going to make it a little easier for us. So I have that right there. Okay. Now, I think what I'm going to do is I'm going to multiply the second equation by -1. Stop and think about why I'm doing that. And you can probably see that, well, if this was a -4x and this is a 4x, I can eliminate x's if I add the two equations. Okay. So let's see, 4x plus 3y equals 12. We didn't change that equation. But the second one we did, -4x minus y equals +4. And now I'll use my elimination. So 4x minus a 4x, no more x's. We got 2 y's and we got 16. Oh, well, hey, y equals 8 then. So I'll go over here if I'm trying to determine this intersection point. This is intersection point 8. For y anyways. How do I figure out what x is? Well, plug into one of the equations. So I could plug it into the second equation, 8 plus 4x equals -4. Subtract 8, so that 4x equals -12. And it looks like x is going to be -3 then. Look at your graph. Make sure this is reasonable. Does it look like x is -3? It seems pretty reasonable. If that said 10, I'd know I screwed up somewhere. Does 8 look reasonable? Well, if y equal to 4 here, oh, that seems pretty reasonable. If it said -10, something messed up. Okay, so that's solving a system of inequalities.